Hello everyone, welcome to thermodynamics. At this point, we are presuming na you have an adequate knowledge on gases and their properties and the laws that govern them. Now, before we get to the mechanics of the first law of thermodynamics, let's try to learn some energy concepts and terms na makakatulong sa atin in the treatment of mechanics for the development of equations for first law and second law of thermodynamics. So there are forms of energy called macroscopic and there are also microscopic forms. Ang macroscopic forms, ito yung pinopossess ng system as a whole with respect to some outside reference frame. So if you have a system like a particle, an object, or maybe collection of particles, titignan mo yung properties ng system na yon and how it changes with respect to the background. So you will not really look into the molecular structure and the different molecular interactions sa loob ng system na yon. And there are two types of macroscopic forms of energy. So meron kang potential energy and kinetic energy. Yung mga microscopic forms naman ng energy, they are related to the molecular structure and the degree of molecular activity. And we measure them in terms of what we call internal energy. Si kinetic energy, bilang isang macroscopic form of energy, it's the energy that the system possesses as a result of its motion relative to some reference frame. And we know that the equation that calculates the kinetic energy is 1/2 mv squared. So alam natin lahat na kinetic energy is the energy due to motion. Next, potential energy. This is the energy that a system possesses as a result of its position in a field. Pag sinabi nating field, pwedeng gravitational field, pwedeng electric field, and some other kinds of fields. And there are many different types of potential energy. So nandyan na nga yung gravitational potential energy, which is the potential energy due to elevation. We have elastic potential energy, such as that you observe in springs and other elastic materials. We have electromagnetic potential energy, chemical potential energy, and nuclear potential energy. And all of these forms or types of potential energy, meron siyang kinalaman bilang isang sort of stored energy, right? So take a look at some examples. So, the gravitational potential energy that you're seeing here, it's the energy due to change in elevation or height. So you have a ball and there's a gravitational interaction between the ball and the earth. So ang nangyayari, as you get the ball higher in elevation, mas tumataas yung kanyang potential energy because you are slowly taking it away from the gravitational field, which is caused by a more massive object, which is in this example yung Earth. So ganun din naman yung nangyayari sa elastic potential energy. As you stretch the spring in this case, mas tumataas yung value ng potential energy. And you all have the corresponding equations here below. Now for electric potential energy, so let's say you have a point charge, tapos negative yung charge na yun. And you have another test charge, which is a positively charged particle, like a proton. So if you take that positive charge away from the field of negative charges, tumataas yung electric potential energy kasi there exists a natural attraction between the positive and the negative charges. Ibig sabihin, pinipilit mong paghiwalayin yung positive tsaka negative charges. So, tumataas yung effort, tumataas yung potential energy. Ganun din naman yung nangyayari kapag, let's say, you have two positive particles or two negative particles. There exists a natural repulsive force between them. So, ang tendency, kailangan nila maghiwalay. Right? But if you push one to the other, slowly and slowly, papunta dun sa isa, kabaliktaran nung example natin dito, tumataas yung potential energy. Now, internal energy, it's a macroscopic measure of the molecular, atomic, and subatomic energies. Anong ibig sabihin nun? And bakit sinabi dito na macroscopic measure siya? Sinabi natin kanina ng internal energy is a microscopic form of energy. So actually, Yes, it's a microscopic form of energy because may kinalaman siya dun sa energy ng individual particles sa loob ng isang system. Okay? So yung collection of particles, for example, let's say collection of gases or gas particles, may mga nangyayari interaction, and each particle pwedeng mag-vibrate, pwedeng mag-rotate, pwedeng gumalaw. So because of all that movement, okay, it translates into energy. However, we cannot measure ang kinetic energy ng isang particle. For example, mahirap gawin yon. And imagine you have a collection of particles and there will be millions of them. So it's impossible for you to directly measure that amount of energy. Kaya sinabi natin na macroscopic measuring internal energy kasi ang tanging paraan para ma-measure natin or magkaroon tayo ng idea doon sa total energy doon sa loob ng system is we try to view it macroscopically. So, sinasabi natin dito na it is known to depend on temperature and pressure. If you increase your temperature, for example, malamang tumataas, according to the kinetic molecular theory, yung galaw ng mga particles doon sa loob ng system. So therefore, internal energy will also increase. So yung internal energy, it's the sum of all microscopic energies, such as translational kinetic energy, vibrational kinetic energy, rotational kinetic energy, and even potential energy from intermolecular forces. Yung mga molecules kasi natin, they do all these motions. They vibrate, and that's the reason why you can obtain IR spectra from different molecules, like stretching, bending, wagging, etc., and all those kinds of vibrating movements. Your molecules can rotate, and your molecules can move from point A to point B. So those motions will result to kinetic energy, and that kinetic energy plus the potential energy from the intermolecular forces will total that of the internal energy. So ibig sabihin, magkaiba yung kinetic energy doon sa loob ng system, yung mga molecules, sa kinetic energy and potential energy ng system mismo. Okay, so please treat them differently. Next important thing that you need to understand is yung enthalpy. So sa enthalpy, yung internal energy U tsaka yung PV work, which we haven't really defined completely, but we'll get to that later. But these two energy terms, madalas makita silang magkasama in thermodynamics. So gumawa tayo ng paraan para ma-describe yung kabuuan ng internal energy at ng PV work, and we call that enthalpy. Ibig sabihin si enthalpy, hindi talaga siya form ng energy, but it's just a way for us to collect these two terms, internal energy and PV work. But to define it, sinasabi natin na ito yung work necessary to create a system and give it a room. So ito yung paborito kong definition ng enthalpy. Again, it's the work necessary to create a system. Ibig sabihin, what kind of internal energy do you have? And give it some kind of volume. So let's make an analogy. Consider this bunch of pencils na nasa kahon, and kapag nasa kahon sila, yung box which is assumed to be rigid, it holds them in place. So yung box, rigid siya, ibig sabihin hindi siya gaanong nag-a-apply ng force on the pencils, so tahimik na nabubuhay yung mga lapis sa loob ng box. Now, assume na kunin mo yung mga pencil out of the box. So kapag ginawa mo yun, they will start scattering kasi wala nang rigid box to hold them in place. So to avoid them from scattering, what you do is you put a rubber band around them to hold them in place. Now you stretch the rubber band, right? Kasi, syempre, you want to give this collection of objects some room. So kapag ginawa mo yun, some energy will go to the rubber band. So yung pencils, they have to apply some pressure against the rubber band para mag-extend yung rubber band and mag-take up ng space yung mga pencils inside the rubber band. So compared to pencils in the box, these pencils will have to constantly fight against the rubber band to stop it from crushing them. So we can use that analogy to understand enthalpy. When a gas is inside the rigid box, its energy is measured by internal energy U. Tama? The gas is similar to pencils. It experiences no force from the box. Pero kapag ni-release mo from the box yung mga pencils and in-expose mo siya sa atmosphere, yung surrounding air, it will try to crush the air from all sides with pressure. And to occupy a volume V, the gas has to do some kind of work, which is we call displacement work, and it's equal to PV, in order to occupy that space by pushing the atmosphere out of that volume. The atmosphere is like the rubber band, always applying a compressive pressure on the gas. So ibig sabihin, kapag we have a gas in an open system, mayroong dalawang components sa kanyang energy. So meron kang internal energy at yung energy na kinakailangan niya to overcome the pressure na parang yung ginagawa ni rubber band to occupy a volume V. So that collection of two components is called enthalpy. Now, nalaman natin yung mga iba't ibang forms of energy. Now, the next question is, paano natin matatransfer ang energy sa isang system? And there are at least two mechanisms to do that. Number one, through heat transfer, which is transfer of energy due to temperature difference. So if at 2 points there is a difference in temperature, heat transfer will occur. And the equation that is used to calculate the amount of heat transfer is what you're seeing right now. And you will normally learn this in heat transfer courses. Now, the second mechanism of energy transfer is called work. Na we a little bit introduced it kanina. And work is basically energy transfer due to mechanical force. So there are different forms of work. Merong shaft work, which is done by a moving part within a system, like a motor or some kind of an electronic device, etc. And you have flow work, which is energy required to push matter, such as fluids, into the system. So yung flow work, siya yung PV work na tinatawag, and we use the equation W equals minus P external dV to calculate this kind of work. So P external is the external pressure outside that collection of particles or yung system na tinatawag natin. So let's have here a picture of a closed system. And what we will try to do is to input some energy into that system. Okay. Now, mathematically, to calculate the change in energy sa system, basically equal siya dun sa kung anong amount ng energy ang tinransfer mo dun sa system. And since we cannot really quantify energy absolutely, nakadepende lang tayo sa changes in energy, kung ano yung energy niya at some point 1 and at some point 2, and take the difference. So that's E2 minus E1. Now, yung tinatawag nating energy of the system, it's the collection or the total of internal energy, kinetic energy, and potential energy. While the energy transferred is normally your heat and work. Kasi sila yung na-discuss natin na mechanisms of energy transfer. So that's equal to E2 minus E1. Now, if you have a case for steady state systems or conditions, there will be no accumulation of energy. Okay? There is no change in the energy content total. Now, if we neglect yung potential energy, and we are assuming that the system stationary, walang motions, ibig sabihin you can cancel kinetic energy, ang matitira lang sa equation natin is delta U equals Q plus W. In terms of differentials, it's du equals dq plus dw. And this equation is now what we call the first law of thermodynamics.